Hi, my name is Kepsi Richard and welcome to my YouTube channel. Today our discussion will be on Discrete Mathematics 1. So far, we have been talking about propositional logic and logical operators. And we said that we have four types of logical operators. These are conjunction, disjunction, conditional and biconditional, as well as the negation of a prepositional logic. Please, if you have not watched that video, please check it out on YouTube. Today, before the video will end, we will learn what compound prepositions are and how to construct truth table for compound prepositions. We will also talk about precedence of logical operators. Then we'll learn how to translate English sentences into prepositional logic. This will be a very interesting engagement, so please watch the video till the end. So our first stop, we'll look at compound prepositions. So when we talk of compound preposition, it's a preposition that involves two or more logical operators. So we learn a lot of logical operators. For example, this is a conjunction statement, this is a disjunction statement, and this is a conditional statement, as well as its negation. So you see that there are about four logical operators here. 1, 2, 3, and a negation. So when you have any preposition that involve more than one logical operator, then that preposition is a compound preposition. Now, when you have a compound preposition, there is a need to construct a truth table for a compound preposition. So the next thing is that we'll learn how to construct a truth table for a compound preposition. So before we learn how to construct the truth table for a compound preposition, let's revise our knowledge on how to identify the true value of a logical operator. For example, a negation. This is a negation statement. And remember we said that when a statement is true, then its negation is false. And when it is false, its negation is true. I hope you will be conversant with that by now. Then this is a conjunction statement. And we say a conjunction statement is true when both statements are true. Otherwise, it is false. Then these are disjunction statements. Remember, we said we have two types of disjunction statement: the inclusive or and the exclusive or. And we say in the inclusive or, the statement is true when at least one of the statements is true and false otherwise. But in the exclusive or, when only one of the statements is true, then it becomes true and false otherwise. Then when we come to conditional statement, we say a conditional statement, there is the hypothesis and the conclusion. And we say that a conditional statement is only false when the hypothesis is true and the conclusion is false. Otherwise, it is true. Then when we come to biconditional statement, we say biconditional statement is true when both statements have the same true value. That's when both statements are false, and when both statements are true, then it is true, but false otherwise. Please, if you have not watched any of those videos, check it out on YouTube. So with our knowledge on how to know when a conjunction statement is true, a disjunction statement is true, conditional statement is true, biconditional statement is true, as well as a negation of a statement, then we don't have problem in constructing truth table for compound statements. So we'll take our first question and see how we can construct a truth table for a compound statement. So let's look at our first question. It says construct a truth table for the statement P. This is a disjunction statement. So P disjunction Q, then conjunction Q conditional. This is a conditional, and the negation of P. So how do we construct that? Please, first, find out if there is a negation. If there is a negation, you need to negate that. So let's look at a situation where P is true and Q is false. Then when P is false and Q is true, when both are true and when both are what? Are false. So the negation of P will be this. Remember, we said when a prepositional statement is true, the its negation is false. So we are negating a P. So since this is true, here will be false. Since this is false, this will be true. This is true, so it will be false. Then since this is false, this is true. Now the next thing is that we need to deal with this. We need to find the P disjunction Q. Remember, this is inclusive OR. So we have P disjunction Q. And remember, when we're doing a bio-conditional statement, this is a bio-conditional, sorry, this is a bio-conditional statement. When we're doing bio-conditional statement, and the inclusive OR for that matter, we say it is true when at least one statement is true, otherwise it is false. So the statement only becomes false when both are false. Other than that, it is true. So we go. Since this is true and this is false, it will be true. This is false, this is true, it will be true. Both are true, it will be true. It is only false when both are false. So remember, this is combining these two. So we need to find the true values for this statement as well. That's Q, the conditional of negative P. Remember, in a conditional statement, we say when a conditional statement is only false when the hypothesis is true and the conclusion is false. So the Q becomes the hypothesis and the negative P becomes the conclusion. So we locate where Q is true and the negative P is false. Then that statement will be false. Other than that, it is true. So we come here. So we locate when P is true and the Q and the negative P is false. That's where it will be false. Then it is true in all respects. Remember that. So now that we have this and this, we can what? We can conjunct them. That's we can combine the two using the conjunction statement. So that's P, the bioconditional Q, then conjunction Q, conditional negative P, like that. So remember, this conjunction. Remember, we say a conjunction statement is true when both statements are true and false otherwise. So we locate when both statements are true. So this is true, it will be true. This is true, it will be true again. As far as one is false, it becomes false. Then we say these are the true value of this statement. This is very easy, provided you are able to form them one by one. Then you combine them. Then you see that it is very easy. So these are the true value for this particular statement here. We'll solve more example on this so that you'll be abreast with it. So let's go to our second question. It says construct a truth table for the proposition this. So how do we do that? So we have P and Q. Remember, the P can be true while the Q is false. Then this can be false while this is true. Both are true, or when both are false. Then the next thing is we need to deal with the negation. Very soon we'll come to precedence of logical operators. You realize that the negation must come first. So we deal with the negation. So we negate the Q. Remember, in a negation statement, when a statement is true, then its negation is false. And when it is false, its negation is true. So we can say, since this is false, this will be true, this is true, this is false, this is true, is false, then this is false, it will be true. Now, we can find our P. Remember, this is a what? A disjunction statement. B disjunction negative Q. And remember, in a disjunction statement, a statement is true when at least one statement is true. Otherwise, it is false. So it is only false when both statements are false. So this is false, this is true, to be true. This is true, this is, oh, sorry. So we are going to deal with P negation Q. So this is true, to be true. This is false, so it will be false. This is true, this is false. It's true. Then this is false, this is true. It's true as well. Remember, in a disjunction statement, is a disjunction statement and the inclusive or for that matter. The statement is true when at least one of the statements is true and false otherwise. So it becomes false when both statements are false. So P, then the disjunction, negative Q. So remember, when this is true and this is true, it will be true. This is false, it will be false. This is true, this is false, it's still true. This is false, this is true, it's still true. Now the next thing is we deal with this. That's P conjunction Q. Remember, a conjunction statement is true when both statements are true. Otherwise, it is false. So we locate when both statements are true, both P and Q are true, then it's true. Otherwise, it becomes false for a conjunction statement. Now, since we have found this and do it, we can find they are conditional. Thus, P disjunction negative Q, the inclusive or for that matter, then the conditional will come P conjunction Q. And remember, a conditional statement is false, is only false when the hypothesis is true and the conclusion is false, and true otherwise. So in this case, this becomes our hypothesis and this becomes our conclusion. We will check when the hypothesis is true and the conclusion is false, then the statement is false and true otherwise. So this is true and this is false, it becomes false. This is false, it's still true. This is true, it's still true. As far as the hypothesis is true and the conclusion is false, it becomes a false statement. Then this becomes a truth value for this statement. I hope you get a clue of this by now. We'll solve one more example on this so that you'll be abreast with it. So there is the next question on the board. It's a construct a truth table for this a propositional statement. Please, you can pause the video and try solving it on your own. Then you compare your answers with mine. So we go. This is P and this is Q. Remember, the P can be true while the Q is false again. This can be false while this is true. Both can be true and both can be false. The next thing is that, please, if there is negation, deal with the negation first. Precedence of logical operators, which we'll be looking at very soon. So now we deal with the negation. So we find negation. There is a negation of P and there is a negation of Q. So deal with the negations first. So we negate the P. So remember, in a negation statement, when a statement is true, its negation will be false and vice versa. So since this is true, this will be false. Since this is false, this is true. This is true, this will be false. This is false, and this will be true. Then we deal with the negation of P2, the negation of Q as well. The same thing. As far as this is false, it will be true. As far as this is true, it will be false. As far as this is true, it will be false. As far as this is false, it is true for this. Since we have found a negation, now we can do the conjunction. That's the negation of P and Q. So the negation of P conjunction Q. So we deal with that. So we have the negation of P conjunction Q. Remember, in a conjunction statement is only true when both statements are true and false otherwise. So we look at the negative P and the Q. We check when both statements are true, there is true. Otherwise, it is false. So let's check. This is false. Both are false here. So it will be false. Both are true. It will be true. So one is false, one is true. It will be false. one is false, one is true, it will be false as well. The next thing is we solve these two. That's P disjunction negative Q. So the next one is a bioconditional statement, a disjunction statement. That's the inclusive or for that matter. And remember, in the inclusive or, when at least one statement is true, then the statement becomes true and false otherwise. So that's a P, then the disjunction negative Q. So we check the P against this. When at least one statement is true, then it is true. So we check this, both are true here, it becomes true. One is, okay, both are false as well, so it becomes false. Remember, when both are false, it will be false. When at least one is true, then it's true. We check the third one, this against that. One is true, so it will be true. We check this against that. One is true, then it will be true. I hope you get that. The last one is the whole of that. That's negative P conjunction Q, then bioconditional P disjunction negative Q. That's this against that. So the last aspect is the conclusion of that. Remember, this is a bioconditional statement. A bioconditional statement is true when both statements have the same true value. That's when both statements are true, the statement is true. When both statements are false, the statement is still true. So let's check that. So let's check whether they have the same true value. So we check this and this. The true value are not the same. Then it is what? It is false. We check here too. The true value are not the same. It's false. We check the true value are not the same. It's false. Then we check this one too. The true value are not the same. Then it is false. So we say that this statement is false in all respects. So that's it. Please, I hope you get this. Solve more, and I know you'll be abreast with this. Please, you have to be convenient with this, because when it comes to equivalency of logical operators, this will play a very important role. The next thing we'll look at is precedence of logical operators. So, if you have been following this video from the very beginning, you see that we have looked at 4 logical operators. Then, included in the negation statement, it becomes 5. That's the negation of a statement, the conjunction statement, the disjunction statement, conditional statement, and bioconditional statement. So we know all the operators by now. Now, what is meant by precedence of logical operators? The precedence of logical operators refer to the parentheses to specify the order in which logical operators must be applied in a compound preposition. So this, to explain this to a layman, it simply means that when you are dealing with a compound preposition, which logical operator must come first? So that's precedence of logical operators. It's very, very important. So when you are dealing with a compound statement, so the first one, the one that must come first, second, third, fourth, fifth, that's in the order. So the first statement that must come is the negation. Very, very important. The negation, we give precedence, we give more values to the negation before any other. That's we give more, we deal with the negation first before any other logical operator. So you look at, when you check, when I was doing the compound statement, I was drawing the true value for them. I will check whether there is a negation. I deal with that negation before I go to any other operator. The second one that must come is a conjunction statement. Very, very important. The third one, the third precedent, is a disjunction statement. Then the fourth one is a conditional statement. And the fifth one is bioconditional statement. So let's say in an objective, they can ask us which of these logical operators must come first in a compound preposition? I hope you know the answer by now. We are going to the most interesting aspect of today's video, where we will learn how to translate English sentences to prepositions. So, the next thing is we learn how to translate English statements into prepositional logic. But before we do that, let's try to revise our mind. We said that a statement becomes a conjunction statement when there is and involved. For example, Kofi and Amma are students. Immediately you see and combining two statements, then we say that statement is a conjunction statement, if you recollect. Please, if you have not watched that video, please check it out on YouTube. The next thing is a disjunction statement. We say disjunction statement is a prepositional logic that uses or. For example, Kofi or Amma is the class prefect. Kofi or Amma is the class prefect. So immediately you see or, then you know that that condition is a disjunction statement. Then we say a conditional statement comes in if we have a statement like if P then Q. For example, if I'm elected, then I will lower tax. Immediately you see such statement, then it's a conditional statement. It becomes a biconditional statement when you meet a phrase like if and only if. For example, I'll lower taxes if and only if I'm elected. So when you meet, you have these phrases in an English statement, then you know which of the logical operator comes into operation. So, what is the importance of translating an English statement into a prepositional logic? The importance is that it removes all ambiguity that the English statement may possess. This will make the statement easy to understand. So, for instance, if I have Kofi and Amma are students, we can split this statement into two prepositions. As far as we have a logical operator and here, then we can split it into two prepositions. And one will be Kofi is a student. This will not change the meaning of the statement. As far as Kofi and Amma are students, then Kofi is a student. And we can say Q, Amma is a student. Then the meaning of translating an English statement to the prepositional logic simply will be P, we identify the logical operator involved, and this is a conjunction. So P conjunction Q. I hope you get that. However, the ones we'll be looking at will not be as easy as this. It will be a compound statement which involves two or more logical operators. So we'll take our first question and see how we'll deal with it. So let's look at our first English statement translating to a prepositional logic. The first one is it translate the statement below to a prepositional logic? If I write examination and I cheat, then I'll get caught and I'll fail. So you those who have been cheating the exam hall, remember that if I write an examination and I cheat, then I'll get caught and I'll fail. Remember, immediately we have if P then Q, then it becomes a conditional statement. So we can say this is a conditional statement. Look at it. If I write examination and I cheat is one aspect of a conditional statement. If you remember well. Then I will get caught and I'll fail becomes another aspect. So we know that this and this becomes the condition. Now in them, there is also another prepositional logic. Look at it. I write examination and I cheat. So I write examination. Look at it. There is a prepositional logic here, and, which is a conjunction. So I write examination, one statement. I cheat, another statement. So we can say that our P should be I write examination. Then this is also another statement. So we say it should be Q. Q. I cheat. I hope you get that. So we split it into that. Then we can have I will get caught and I will fail. So since there is and here too, it becomes a conjunction. So it's combining two statements again. So we can say we should let R to be I will get caught. I will get caught. Then our S becomes I will fail. So look at it. So now the first one, I write examination and I cheat. That's P conjunction Q. You can say that since N is combining the two. So you can say the first aspect of this statement is P conjunction Q. So we can have P conjunction Q for that one. The second aspect, I will get caught and I will fail. That's R conjunction S. So we can say that one too is R conjunction S. Then there is a condition combining the two of them. That's a conditional statement. So this is the hypothesis of a conditional statement, and this becomes a conclusion. The conclusion is that I'll get caught and I'll fail. So we can say that this whole statement as a prepositional logic will be P conjunction Q, then a conditional statement R conjunction S. I hope you get that. So this long English statement is reduced to a simple proposition. I hope you get that. We'll solve one more example on this so that you'll be abreast with it. So we'll look at our second English statement, which says that it is raining if and only if the ground is wet and the sky is dark. So please, you can pause the video and try translating this English statement to a propositional logic. Remember, if you have if and only if, then that becomes a bioconditional statement, having a hypothesis and a conclusion. So we can say that it is raining is the hypothesis. Then if and only if, remember that this becomes a bioconditional. Then the rest becomes the conclusion. So it is raining if and only if the ground is wet and the sky is dark. So look at it. The ground is wet and the sky is dark. There is and there, a conjunction combining the two again. We have two statements there. The ground is wet being one and the sky is dark being another, if you look at it very well. So we have three propositional statements here being combined to form a compound statement. What are they? The first one is P, it is raining. And this is the hypothesis of the bioconditional statement, if you remember that. Then Q can be the ground is wet. So the ground is wet. Then we can have R, the sky is dark. The sky is dark. So we can say that the ground is wet and the sky is dark is a conjunction statement. So that one, you can say Q conjunction R. This being the conclusion of the bioconditional statement and P being the hypothesis of the bioconditional statement. So we can say this whole English statement will be translated to a prepositional logic as P if and only if Q and R. I hope you get that. Okay, this is very simple. So this whole English statement is translated to a simple propositional logic. Remember, when we do that, it removes all ambiguity that a statement may have. We'll solve one more example on this, then we call it a day. So we'll look at our last statement translating to a logical operator. But before we do that, please remember to do 4 things for me. Please like my video, share, comment, and subscribe to my channel if you are yet to. This will make the channel grow and I can share more mathematical content with you. So please now pause the video and try to see if you can translate the English statement on the board to a logical statement. The statement is that you can access the internet from campus if and only if you are not a computer science student or you are not a freshman. So this is just accessing internet from campus. You can only access that if you are a computer science student or you are not a fresh student. That's you are not a level 100 student on campus. So fresh students in the university are known as the level 100 students, or the freshmen who comes to school. The level 100 are the freshmen, if you remember that. So remember, let's take it. You can access the internet from campus if and only if. So that becomes a bioconditional statement. And remember, anytime you have a conditional and a bioconditional statement, there is a hypothesis and a conclusion. So let's locate the hypothesis. So you can access the internet from campus. If you look at it, there is no any logical operator in that statement. And you can say that becomes one aspect of the proposition. So we can access the internet from campus. So if and only if, remember, that becomes the logical operator, the bioconditional, joining that. So this becomes the proposition, the hypothesis, and the rest becomes the conclusion. So the rest here becomes the conclusion. Now let's look at the rest and see if there is any logical operator involved. Look at it. You are a computer science student, or look at it, or it's a logical operator, which is a what? A disjunction statement, if you remember that. So you are a computer science student, one statement, or you are not a freshman. Also, you are not a freshman. Because of the not here, there is another logical operator involved. And that logical operator is a negation. That negation simply means you are a freshman is the statement. And it is negated, not. So that means we negate that statement. So now let's break them and see how we solve it. The first one, you can access the internet from campus, being one statement. So you can access the internet from campus is one statement, being the hypothesis of the statement. If you are a computer science student, it's also one statement. You are a computer science student. So we can say Q is you are a computer science student. Computer science student. Then remember the statement is you are a freshman. Is the statement before it is negated. So we can say R should be you are a freshman. You are a freshman. So since we have this where there is a logical operator combining the P and the R, then we can deal with that. Remember the R will be negated because of the not. That's the negation. So we can say that you are a computer science student or you are not a freshman will be Q. Remember, or is a disjunction statement. So P disjunction negative R for that. Remember, we negate it because of the not a freshman. The statement actually should be you are a freshman. So when it is negated, not a freshman. And this becomes the conclusion of the statement. Then you can access the internet from the campus. Become the hypothesis. So we say that P, remember it's a bioconditional statement, bioconditional. Q, then negation of R. So this becomes this long statement here is being translated to a simple logical operator. I hope you get it correct as mine. We'll end it here today. Please, until we meet again on Discrete Mathematics 1, my name is Teteji Kepsi Richard.